Hello, and welcome to the video on symmetry. If you can reflect or flip a figure over a line and the figure appears to be unchanged, then we say that the figure has reflection symmetry, or in other words, line symmetry. The line that you reflect over is called the line of symmetry. A line of symmetry will divide a figure into two mirror image halves. The dashed lines on the figures below indicate lines of symmetry. These figures all have line symmetry. Now, on the next set of figures, although all of the lines divide the figures into two equal pieces or cut them in half, they don't create mirror images and therefore are not lines of symmetry. Now, on your paper right now, I want you to pause the video and answer the question, what is line symmetry? And then once you've answered the question, what is line symmetry, you can go find all of the lines of symmetry that you can for the figures on your paper. When you are done, go ahead and resume the video. Excellent. Now then, we have some specific types of line symmetry that we need to talk about. We say that a figure has what's called vertical line symmetry if you can draw a vertical line through the figure in such a way that the left side and the right side aren't mirror images of each other. So that green dotted line would be a vertical line indicating that this image does indeed have vertical line symmetry. Horizontal line symmetry works the same way, except that instead of drawing a vertical line through the image, we're able to draw a horizontal line through the image such that the top and bottom halves are mirror images of each other. We say that a figure has both vertical and horizontal line symmetry when we can draw a vertical line such that the left and right side are mirror images of each other, and at the same time a horizontal line in such a way that the top side and the bottom side are mirror images of each other. Now, at this point, I want you to pause the video again and go find all of the lines of symmetry for the regular polygons on your paper. See if you are able to generalize a rule about the relationship between the number of lines of symmetry for a polygon and the number of sides that it has. All right then, the last part of our lesson today has to do with rotational symmetry. We say that a figure has rotation symmetry if you can rotate it, or in other words, turn it, around a center point by somewhat less than 360 degrees, and at the same time having the figure appear unchanged. All right, so let's come up with a definition for this. We say that a figure has rotation symmetry if you can turn the figure around a center point by less than 360 degrees while making the figure appear unchanged. The point around which you rotate is called the center of rotation. And the smallest angle you need to turn for the figure to coincide with itself is called the angle of rotation. At this point, I want to go play a little bit and show you some angles of rotation and what exactly this means. Alright, so if we want to determine the angle of rotation for the image below, what we're trying to do is find the fewest number of degrees that we can rotate it in such a way that it will coincide with or land on itself. So I'm going to go ahead and pull this figure up, and if I think about a full rotation as being 360 degrees, then 180 degrees would be half of a rotation, and 90 degrees would be 1/4 of rotation. So I'm just going to play a little bit, and I'm going to go ahead and see what would happen if I rotate this figure 90 degrees. So 90 degrees would be 1/4 of a complete turn, or of a complete rotation. And when I rotate 90 degrees, I see that the image is almost corresponding on, or landing on the pre-image, but not quite. I have to go a few degrees further than 90. So maybe I'll try something like 120. And if I rotate 120 degrees, then what I find is that the image coincides with the pre-image, and thus the angle of rotation for this particular figure is 120 degrees. Notice that the center of rotation, the point upon which my figure is turning, is that center point right there. Alright, if I want to go try another one, maybe I'll try this hexagon. And again, maybe I'll try 90 degrees first, which is a 1/4 turn. And if I rotate 90 degrees, I can see I went a little bit further than I really needed to in order to get that figure to coincide with itself. So I know I'm going to need to go something less than 90. I'll try 75. And again, I went just a little bit too far. So now I'm going to try something a little less than 75. I'll try an angle of 60 degrees. And if I rotate an angle of 60 degrees, I find that the image coincides with the pre-image, making the angle of rotation for this particular polygon 60 degrees. Alright, this looks like a fun figure, so I'm going to play with this one next. And again, I'm thinking I'm going to try that 1/4 turn, or that 90 degrees, first of all. And when I rotate 90 degrees, I find that the image ends up exactly on top of the pre-image, making the angle of rotation for this particular figure 90 degrees. At this point, I'm going to stop again and ask you to pause again and go back to your note sheet, and for each polygon, identify the center of rotation. And then once you've identified the center of rotation, see if you can determine the angle of rotation for those polygons. Alright, the last idea that I'm going to bring up in order to wrap up this video is the letter Z. And I want to check and see again what its rotation symmetry really is, or what its angle of rotation is. So again, I'm going to start with 90 degrees and see what happens. And at this point I've gone 90 degrees and my image does not coincide with the original, so I know that I'm going to have to go farther than 90 degrees in order to make that happen. And when I rotate 180 degrees, I find that the new image is exactly the same as the pre-image. So my angle of rotation for the letter Z is 180 degrees. And that breaks up a very, very special kind of symmetry. We say that anytime a figure has 180 degrees of rotation symmetry, the name that we have for that is point symmetry. So point symmetry, we're going to say that a figure with 180 degrees rotation symmetry has that special point symmetry also. A little trick that you can use for determining whether or not a figure has point symmetry is to know that it will appear exactly the same upside down as it did when it was right side up. So the little trick that I'm going to give you to remember is to flip your paper upside down and ask yourself the question, does this figure look the same upside down as it did right side up? And if the answer to that is yes, then your figure does have point symmetry. If the answer to that question is no, then your figure does not have point symmetry. At this point, you should be able to answer the question at the bottom of the page, and you are now done with your homework and ready to come in and practice some things with symmetry in class tomorrow. All right, bye for now.